All right, guys, on this video, we're going to look at multiplying fractions times a whole number. And so this video is pretty close to the last one that I did that was finding parts of a group. Only this time, we're going to look at an example of them taking this and putting it into to a number line. And so if you ever see a number line pop up on a test, there's multiple ways that they could ask you questions about it, but one of the ways could be multiplying fractions. And so you won't see it on this page, but I thought we could at least go back over what the algorithm was going to look like, how to solve these problems, and then we'll look at it on a number line or two. Okay, so on this one, this is pretty easy. The algorithm to these stays pretty easy. I think probably what I would do when I teach this is I just try to relate this back to what multiplication is. You know, remember, multiplication is just repeated addition. And so when I look at this problem here, I see 1/4 times 5. The reality is I just see 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4. And so we have the right to do that problem. I mean, if we want to set that up, we can. But I don't think we need to. I think we're smarter than that. We're fifth graders. So 1/4 times 5 could look something like this. I'm going to keep the 5 wholes, but I'm going to write it as a fraction, 5/1. And so I'm just going to multiply from left to right. 5 times 1 is 5. 4 times 1 is 4. And then I'm going to think about where I'm sitting at. And, you know, again, this is why we've been doing all these lessons with fractions over the last several months now, or it seems like several months, where we're seeing this and we're thinking, okay, well, what do we know about 5/4? 5/4 is improper. 5/4 could be changed to a mixed number. So I would think, okay, what is 5/4 really? Well, 5/4 is 1 whole and then 1 extra fourth. Or in this case, 1 1/4. 1 1/4 would be your final answer. So not a hard concept, not a very hard problem either. It's just taking what we've learned and just kind of extending it. This problem, again, I'm just treating this like 2/3 times 7, or 2/3 being added basically 7 times. And so when I were, maybe start this problem, I might think that, but the easy way out here is still to think, okay, 2/3 times 7 is the same as 2/3 times 7/1. If I know my multiplication facts, 2 times 7 is 14, 3 times 1 is 3, and then I just go to work on whatever I have. 14/3, 14/3 is improper. So in my mind, I'm thinking really this is just 14 divided by 3. I'm asking myself, how many times will 3 go into 14? I know it can go in, can't go in 5 times. 5 times would take me to 15. So it would have to go in 4 times. Then 4 times 3 gives me to 12, which means I would have 2 left over. And then I'm still using thirds on this, so it would remain thirds, or final answer of 4 2/3. Again, not hard. Stuff we've done before. It's just an extension. Now it just looks a little bit different because we're multiplying with some fractions. All right, so on this page, what I thought I'd at least show you is how you could use this type, same type of math, but use it looking at a number line. So what we're going to look at here is we're going to look at a problem that could be used on this number line. And so I'm sitting here, first of all, one of the things that I think this is really, really critical, and this is not just multiplying fractions, this is really anything when it comes to math. When you get something like a number line in front of you, know how to read the number line. That is critical. And I think a lot of kids learn it at an early age, but then they forget it as they go through their years in math. But I mean, a lot of times on these problems, if they give you a number line, man, they're giving you an answer almost, because you can use the number line to find your answer. And so learn how to read number lines. So that's the first thing I want to talk about. So on this one, I would really want to look at the 0 and the 1, because that's going to tell me what it's cut into, or in other words, what is it counting by. So if I want to look carefully here, and I'm just going to use some dots, I'm going to count the spaces that are in between the lines. I know some teachers will always teach counting the lines, or I've heard that some teachers teach, counting the lines. I don't like counting the lines. I like counting the spaces, because sometimes kids will get it like that. They'll look at it and they'll get confused. They'll throw in an extra line, or they'll throw in an extra part or a piece to the number line. And to me, if you can look at those spaces in between, then you truly know what it's cut into. So this one here is truly cut into fifths. So this number line is counting by fifths. And so I'm going to come up with a problem with fifths here. I'm going to say, okay, what if we had 2/5 and we times 2/5 by 7? All right, so let's just kind of see what that would look like. First off, I could go back to the previous pages and I could just use algorithm here. I could just go straight algorithm. Or what you might see on a test is you might see this modeled. And so there's different ways they could model this. I've seen them use like jumps, like little loops, which we kind of saw back when we did decimals. I've seen them where they almost kind of like shaded in. They might use like a rectangular shape or something and shade it in where it almost kind of looks like a fraction strip. I've seen them do it that way. Probably how I'm going to do it today, just the easiest way that I could show you on this app that I use, is probably just make the jumps. But just keep in the back of the mind, or back of your mind, what you're doing here. You're just repeating 2/5 7 times. So if I really were to look at this problem, I could start by going, okay, if I made a jump here and I made a jump to 2/5, basically that's two of those spaces that I was talking about earlier, then I'm just doing that though, but I'm doing that 7 times. So I'm going to try to follow this here. I want y'all to follow me and see if I can get it down. So there's another jump of 2/5. There's another jump of 2/5. There's another jump of 2/5. So if I pause here and I kind of think about what I've done so far, I've made 4 jumps. So I've basically repeated it 4 times. Well, I'm not done yet. That's 5. That's 6. And then that's 7. Okay, so I'm going to make a little mark there. I want to see if that mark comes back into play here in a second. Okay, next part, let's just kind of go and look at what the algorithm would look like here. So if I were to solve this, I would probably just think, okay, 2/5 times 7 could be 7/1. 7 times 2 is going to be 14. I can do multiplication here at the bottom. 5 times 1 is 5. And so I'm going to get an answer here of 14/5. Well, 14/5 is really just a division problem, 14 divided by 5. Well, 14 divided by 5 means how many times can 5 go into 14? It can go in twice. That would take me to 10. That would be 4 left over. And then the denominator of fifths would not change. So let's now see if what I did with the model makes sense. If what I did at the top really gave us 2 4/5. So again, my jumps, I'm just going to number them here. My jumps are basically me timesing it by 7. And so I have the same thing happening here 7 times. But I stopped right there where that dot is. And I think if I now go and compare what I got with my algorithm to what I got, with my actual model, I should have the same thing. And so if I look here, yeah, where that dot is, that's 2 4/5 all day long. I mean, it's past the 2, so it's at least 2. And it's cut into fifths, and I'm at the 4th mark. So yeah, if I label that, that's 2 4/5. So not too bad there. All right, last thing here, I'm just going to do another quick example. I'm not going to talk as much on this one because we've gone over a number line. But the first thing I would want to look at here is, what is this cut into? So if I count those spaces again, that's 1, 2, 3, 4, 5, 6, 7, 8. This one's cut into eighths. So I'm going to come up with a problem on this one. I'm going to say, okay, let's do 3/8, and I'm going to times that by 4. All right, so 3/8 times 4. Let's start with algorithm first. Let's just go and see where that takes us. So 3/8 times 4 is going to be 4 times 3 at the top, which gives me 12. 8 times 1 at the bottom, which gives me an 8. And so now I'm looking at it and I'm thinking, okay, well, This is 12/8. I want to see how many times 8 can go into 12, which is going to be 1 time. There's going to be 4 left over, and then the denominator's not going to change. So I'm going to get this answer of 1 4/8. Well, 1 4/8, you should know by now that 4/8 could be simplified, or you really should just know it's just going to be a half. So I bet whatever I do with the number line up top, I should get an answer that is 1 1/2. Okay, let's look at the number line, and let's see if we can truly get that 1 1/2. So I'm going to start at the 0, and I'm going to make a jump of 3/8. So basically those 3 spaces is what I'm looking for. And so I'm going to make 1. I'm going to go make a second one. I'm going to go make a third one. And then I'm going to go make a fourth one. And wherever I stop should be 1 1/2. Which, if I put a dot there, I think most of you would agree that are watching this, that's right there at 1 1/2. So again, not a hard concept. I think the math for this should be pretty easy. You're going to understand the algorithm. This shouldn't be too difficult. The models, not too bad either. We've seen number lines a couple of times. It's just been a while since we've seen them. So try to put these two things together and see if you can't get these problems taken care of. It's pretty easy stuff.